Alright, today we're going to go over some of the theorems relating lines and planes. Alright, so we're going to discuss the wording and then we're going to draw a picture for each one. So for theorem 1, it says, if a line is perpendicular to each of two intersecting lines at their point of intersection, then the line is perpendicular to the plane determined by them. So let's see what this looks like. Alright, if a line is perpendicular to each of two intersecting lines at their point of intersection, then the line is perpendicular to the plane determined by them. When it says by them, it's referring to the two intersecting lines at their point of intersection. So, let's say we have one line going this way, right, and we have another line going this way. Okay, those are two intersecting lines and they have a point of intersection, and these two lines determine a plane. Okay, we could draw a plane that these two lines lie in this plane. Okay, any two intersecting lines always determine a plane. Think about these two pencils intersecting. Right? I can always put a flat plane right underneath them, right where they intersect. No matter how they intersect, they always form a unique plane. Okay? So, there I have two lines, and I have the plane that they're lying in. Now it says, if a line is perpendicular to those two lines at their point of intersection, so now what I have is, here's their point of intersection, and I have a line going straight up in the air. Okay, now this line is actually going straight up in the air. And it's perpendicular, so I'm going to draw a right angle to this line. Okay, and it's also perpendicular to this line. So it's perpendicular to both planes. Okay? Now, what this theorem says is, if this line is perpendicular to both of these two lines, alright, so what we have essentially is two lines on the ground, and then we have a line coming straight up at 90 degrees, okay, to both of those lines. Well, this line that's coming straight up, it's not only 90 degrees to these two lines, but it's also 90 degrees to the plane that those two lines determine. Alright? So it means that not only does it come straight up from those two lines, but it also comes straight up from the piece of paper that's underneath those two lines. Okay? So this would be the picture for ours, and then this wording down here describes the same exact thing, so let's just label it. Let's label that line T. Let's put a C here and a D here and a B here and an A, so line AB and line CD, and this could be plane L. Alright, so let's fix that down there. It should be L. Okay, so let's look at theorem 2. Through a given point there passes one and only one plane perpendicular to a given line. Okay, through a given point there passes one and only one plane perpendicular to a given line. That means that if we have a plane, now we can draw a plane any way we want. Alright, it just represents a flat space. So let's say that's our plane this time. So through any point, let's draw a line now, going this way this time. Alright, it's coming and it's going in and it's hitting this plane, and then it's behind the plane, so we draw that dash, and then it comes out and continues on the rest of the way. Alright? And let's call this plane L, and this point that it intersected the plane at, let's call that A, and then let's label this other parts of the line B and C. So through a given point there passes one and only one plane perpendicular to a given line. So you can only draw one plane that's perpendicular to a line. So this plane, alright, so here's my right angle mark. It's actually coming down and touching that plane. Alright, so let's see here. If you imagine that this paper clip, alright, is that line, here's what this picture is representing. Okay, so you have this plane, right, and it's on its side, but that's how we would draw it on its side. It would look something like this. So then you have this line going through the plane, okay, and it's going through the plane so that it's exactly sticking out perpendicular at a 90-degree angle to this plane. So right now it's on its side, right, and you see how the part behind the plane, you can't see the part of the line for a little bit behind the plane. That's why that part of it's dashed back here. Alright, but so what we have is we have this line coming straight out of a plane, and it's exactly perpendicular to the plane. Okay, it's not at an angle, it's at a 90-degree angle. So we drew it on its, a little bit on its side, looking like that. Okay? Let's look at the next theorem. Through a given point there passes one and only one line perpendicular to a given plane. This is basically the exact same thing as the last theorem. So let's just draw essentially the same picture that we had before. Okay, so let's say it crosses here, comes this way, and then it's behind the plane, and it comes out this way. And again, it's perpendicular to the plane. Same picture, change this. Nothing is different here. Okay, let's go to theorem 4. Two lines perpendicular to the same plane are coplanar. Okay, two lines perpendicular to the same plane are coplanar. Alright, so here's how we're going to draw this picture. If we have a plane, let's draw it like this. Okay, what we're actually going to be drawing here is two planes, so you're going to have to follow me very closely on this one. Okay, now what we have is okay, we have two planes that are intersecting. So you could imagine like two index cards, you know, one's intersecting another card, going through it. So check something. So for instance, if I cut this card, let's see if this will work. Alright, what we have is two planes intersecting like this. Okay? They're intersecting. So what we did is we drew the best picture we could. Essentially what we drew is this. Okay? We drew it as best we could, that, in 2 dimensions. So we have two planes that are intersecting each other. Okay? So this line right here where they intersect is this line down here in the middle where they intersect. Alright, now let's see what it says. Two lines that are perpendicular to the same plane. So let's say we had a line coming down here like this, and another one coming down here. So two lines that are perpendicular to the same plane. Alright, so that means let's make them both perpendicular to this plane. Okay? So what we essentially have is this, and we have a line coming straight down here that's perpendicular to this top plane here, and another one right next to it that's exactly coming down at a 90-degree angle into that plane down here. Alright, it's at a 90-degree angle and it lies in this other plane. Okay? So what this theorem says is if two lines are perpendicular to the same plane, so these two lines are perpendicular to this plane going at this angle, then those lines are coplanar, and you can see that these two lines lie in the same plane. They lie in this plane, the other plane. Okay? So they're not lying in the plane that they're perpendicular to. They lie in a different plane. Okay? So let's just label this now. Let's put a Q up here, and let's change this little q to a big Q. Oh, see. And this is plane L, this other slanted one, so let's change that to a capital L. Planes should always be labeled with capital letters. And now let's label these lines A, B, and C, D. Okay? Let's look at the next side or the next page, Theorem 5. It says two planes are perpendicular to each other if and only if one plane contains a line perpendicular to the second plane. Okay, so let's draw another picture here. It's going to draw it a little differently this time. Alright, so just follow me. It takes practice to figure out how to draw these things. Okay, so let's say like right here I come down. Okay. Now what I have is okay. Okay, so this time I drew the two planes crossing that way. So essentially what we have is this, okay? And I just drew that in 2 dimensions. Alright, this is what we have right here. Okay, 2 planes are crossing again. That's what it is. It's 2 flat spaces crossing. So if 2 planes are perpendicular to each other, so these 2 planes are at exactly 90-degree angles. That means they make an exact X, or a plus sign. Right? They're at exactly 90 degrees to each other. Now it doesn't matter how I hold it, as long as these 2 planes are exactly 90 degrees to each other. So you can imagine a little box in here. Okay? They're at a 90-degree angle to each other, at a right angle. So we're not like this, we're at exactly 90 degrees. So if that's the case, then that means that one of the planes must also contain a line that's perpendicular, okay? To the other plane. Like that. Okay? That's it. Now let's just fix this. Get rid of that little Q. That should be a big Q, and this should be a big L. Let's label this plane Q, this plane L, and then let's make this line AB here. Okay? Make that little Q a big Q, and this should be a big L. That's theorem 5. Now let's look at theorem 6. Alright, we're going to draw a similar picture to what we just drew. Okay. Alright, so basically the same type of picture. This one says, if a line is perpendicular to a plane, then any line to the given line at its point of intersection with the given plane is in the given plane. Okay? So, if we have it like one of those perpendicular lines, like this line lies in this plane, and it's perpendicular to this plane. So if a line is perpendicular to a plane, that's what we have. We have a line perpendicular to this plane right here. Okay? This whole one that goes this way. Then any line perpendicular to the given line at its point of intersection. So now, let's say here's the point of intersection. Let's say we had another line going this way. And also it goes behind the plane, right? And it would come out the other side. Right? Just like this one here is really going behind here and coming out. Let's fix this picture up a little bit. Let's make this line also going behind here and coming out. And the other two are fine. The other ones are fine. So, if this line is perpendicular to this plane, then this line that intersects this other line at a perpendicular angle also is going to lie in this plane. That's all it says. Okay? These theorems sound really confusing, but they're just like pointing out things that are obvious. Okay? You just have to, the hardest thing here is that you have to be able to visualize what these things look like. Alright? So that's why we're drawing these pictures. So let's just fix this. This should be a capital L. And this should be a capital L. And let's label our picture. This is capital L. This is Q. Let's make this point B. And then we'll say this is A and this is C. Alright, let's look at theorem 7. Theorem 7 is essentially the same picture as theorem 5 and 6. So let's just get a little more practice drawing it. Okay, same thing. Let's make this L and this Q, and we have that line coming out again, and it's perpendicular to this plane. Okay. If a line is perpendicular to a plane, that's what we have here, a line perpendicular to this plane, then every plane containing the line is perpendicular to the given plane. So that means that these two planes are perpendicular. If this line is perpendicular to this plane, and this line is lying in this plane, then this plane must be also perpendicular to this plane. So let's just fix these letters. Capital L, capital Q, capital L. Number 8. Number 8 is the toughest picture we're going to have. Okay? So let's take our time on this one. Alright. Okay. Take your time on this one. Okay, that's our picture. Alright, what we have is, let's see, we have this big long plane down the middle, right? And then so we have this big long plane down the middle. Then we have another plane coming in and intersecting that plane. Okay, we have one there, and we also have another one coming down and intersecting it here. So we have two planes intersecting another plane. Okay, it looks like that. So now, if a plane intersects two parallel planes, so this plane and this plane are parallel, Okay, these two planes are parallel. So when I hold these two planes, I have to hold them so that they're going in the same direction. They're exactly parallel. They'll never intersect. And then if you take this big plane and you intersect those two parallel planes, then the intersection, okay, which is this line right here, and this line right here, those lines will be parallel lines. Okay, so we could put feather marks on those lines. They'll be parallel. So let's just label this. Let's say this is plane Q, this is plane L. Let's say this is plane R. And this would be A, B, and C, D. So if L is parallel to R, then line AB is parallel to line CD. This would be if plane L is parallel to plane R. That's why they're capital letters. Alright? And we have one more theorem to draw. Theorem 9. If two planes are perpendicular to the same line, they are parallel. So this is what this looks like. Let's say we have one plane like that. Alright, and we have another plane right next to it like that. So we have two planes next to each other. Now if we have a line that goes through both planes, right, like that, and it's perpendicular to both planes at their point of intersection. So this line is perpendicular to both of those planes. If that's the case, then these two planes are parallel. Alright? That means the two planes are exactly side by side and parallel. Okay? Just like this, or like this, or like this. Alright? Which means they're not crooked to each other. They'll never intersect. They're exactly parallel. Okay? Whether they're like this, or like this, or like this, doesn't matter. They will never cross. Okay? They're parallel planes. So let's just fix the labeling here. Let's say this is L1 and this is L2. Let's call this D, B, A, and C. So if L is perpendicular to line DC, this is not L2, let's just call this L. So we have L and L1. If L is perpendicular to line DC, and L1, L sub 1 is perpendicular to line DC, then L is parallel to L1. Okay? Let's look at the examples. In this rectangular sided box, which set of sides lie in the same plane? And then give us choices. We have to choose one. They have EF and DA. Alright, those don't lie in the same plane, right? This one's going here, it's over in this plane, and this one's going this way, it's in these two planes. Okay, this line is in these two planes. So it's not that one. GH and FC. GH is here, FC is here. Okay, those do not lie in the same plane. FC is in this plane, and also on the bottom plane. And GH is on these two side planes. So, not those. Then we look at AB, which is here. So AB is on these two planes. And BC, which is right here, is on the right plane and the bottom plane. So they're both on this right plane. So it would be that choice. Okay? Because they both are on this plane. AB is on this side of it and BC is down on the bottom edge of it. But it doesn't matter, as long as it's on the plane, it counts. Okay, let's look at the next problems. When two planes intersect, two lines are formed. Is that true or is that false? Alright, well, we remember our theorem. Or let's go back. Look what happens. You see this plane and this plane? You see how they're crossing? Look what's formed. They cross at one line. Here, let's draw a picture, because this is confusing because you're seeing two lines, but that's different. All you got to do is picture, say you have a plane like this. And it's crossed by this other plane. Right? Look where these two planes cross. What do they form? Do you see this? This is where they intersect each other, right? If I pull out my index cards again, if I have two planes that intersect, where they intersect, okay, is along this whole entire line right here. It forms a line. You see that? Where the planes intersect, where two planes intersect forms a line. Okay? It forms a line. So two lines are formed is false. Only one line is formed. Which of the following statements is true? Planes L and Q are parallel planes. No, we know they're not parallel, they're intersecting. It's not that. Planes L and Q intersect in line DE. That's not true. They intersect along that line, right? Line DE is this line. It's not this line. If it said this line, we would be choosing that, but it doesn't. Point P is in plane L. You could see point P over here. It's lying in plane L. This is plane L. This white plane. So that's the choice. Number 4. If two lines intersect, only one plane contains both lines. True or false? That's true. Alright, that actually is that one of our theorems? It's kind of part of theorem 1, because it says two intersecting lines, and then it says the plane determined by them. Any two lines always forms a plane. Okay, you have to know that. If I put two lines down right here in midair floating, right here, these two lines, they form a plane. Okay? They form that plane right there. And no matter where I put these two lines, they form only one plane. Alright, it's the plane that would be attached to them wherever they are. So two lines form a plane. So let's see, if two lines intersect, only one plane contains both lines. That's true. For this rectangular solid, plane GHB, where's that? GHB. That's this one back here. And EFC. EFC, that's this one here. Okay? They want to know what those two planes are. Well, you have one plane in the back and you have one plane in the front, right? And those planes are exactly parallel to each other. If we looked straight down on this box, right, we would see the front and the back of the box, and they would be exactly parallel. And the sides would also be parallel, right? So we want to choose the second choice. But number 6, which of the following statements is true? Line segment BC lies in plane L. No, it goes through plane L. If it lied in plane L, it would be lying in it like this, or like this, but it won't go through it. The intersection of line segment BC and plane L is a point A. No, it doesn't intersect it here, it intersects it down here. It does intersect it at a point, right? A line always intersects a plane at a point, but it didn't do it at point A, so that's not it. Plane L is perpendicular to line segment BC. Okay, we could see that this is perpendicular right there, so it's that choice. If 2 points lie in a plane, the line joining them also lies in the same plane. True or false? Well, that's obviously true. Think about it. If you have a plane, right, and you have 2 points lying in the plane, then if you connect them with a line, that line is also lying in the plane. So it's true. And the last one, for this rectangular solid, which planes contain D and are parallel to plane FEG? FEG. FEG is this plane on the side over here. This is FEG. So it's got to contain D and it's got to be parallel to FEG. Well, there's only one plane that's parallel to FEG, and it's this plane over here. And it contains D on its corner. Okay? So planes DAB and GAD, no. Planes DCB, and no, it's only one, only plane DAB. Okay? And that is the end of the lines and planes theorems lesson.